Here from basics, we are going to start with the networking. Okay. The first thing we are going to learn is communication. Here you have 4 types. Okay. First one is unicast. Unicast means what? It is a one-to-one communication. Okay. If a sender is sending a information to one particular person, for example, 5 of you are there. Okay. I want to send some information only to Hari Krishna. Then what I'll do, go to the WhatsApp chat. Correct, individual WhatsApp chat. I'm going to say, okay, Hari Krishna, this is the details. Then that information is only for him. That is called one-to-one. What is this multicast? That means one to many, right? Consider a scenario. Tomorrow we are going to sit in a different classroom. Okay, instead of this classroom, I'm going to sit in a third floor classroom. Is this information relevant to online guys? Yes or no? Why? Because it doesn't matter where we sit and do the class. They are anyway connecting online, right? It's that information is only relevant for the offline guys. So I will say offline guys, tomorrow move to the third floor classroom. Then automatically you guys will come there, right? And otherwise I can simply mute myself. And if I say, okay guys, sit in third floor, will they listen online guys? No. This information is not relevant to them. So it is what? Multicast means one to a specific group. I am giving that information only for the offline guys. That is called multicast. What is broadcast? Okay, broadcast means one to all, meaning tomorrow I'm going to change the timing of the class. Instead of 2 to 4, I'm going to change it to 3 to 5. Okay. Is this information relevant to online? Of course. Offline also relevant because everybody attends the class, right? In that scenario, I'll say, okay, guys, CCNA 2 to 4 p.m. guys, tomorrow's class is 3 to 5. Then that information goes to everyone, right? When I use the term guys, CCNA students, right? That is called one to all. So unicast is one-to-one communication. Multicast is one to a specific group or one to many, you can say. Broadcast is one to all. And then comes this anycast communication. Here is where people will make the confusion. What is this anycast? Okay, here is where the problem comes. What is anycast? They will confuse whether I should say one to one, one to many, one to all. They are not aware of it. Okay, in an interview, if they want to start a basic level of question, they're going to ask you what is the difference between unicast and anycast. That will be the basic question to start with. Okay, if a person is not even able to answer the basic question, then they will think, oh, okay, he is technically this much level only. Okay, so basics are as important as the technical things. What is this anycast? This is also one-to-one communication, but one to the nearest one. Okay, consider I'm saying www.google.com. Okay, I'll connect to my Google server, right? So Google will have a server in US. Okay, likewise, there will be another server in South America. There is another server in North America. One server for Asia. One server for China. Likewise, they have multiple different servers, right? Or will Google have only one server for entire world? They will have multiple servers. If I am here, I will be connecting to the server which is near to India. Correct? If there is a server in Mumbai, then I will connect to that Mumbai server, right? IP will be same, but whichever is nearby, I am going to connect to that particular server. Okay. Or if you want to ask me a real-time kind of example, I want to pass some notebook to the Pinky. Okay, she is sitting at the last row. I have to pass this book, so I'm passing like this. So who will come? Hari Krishna will come or you will come? You are nearby, correct? So you will come and get it. Is there any rule you have to come? No. Is there any rule he has to come? No. Whoever is nearby, I'm just passing to them. Then you will pass it to her, right? Same thing. So whoever is the nearest server, I will get connected to that particular server. That is called anycast communication. So anycast is also one-to-one, but one to the nearest one. Okay. And it works only in your IPv6. We don't have anycast communication in IPv4. Only in IPv6 we have. So when a question comes, what is the difference between unicast and anycast? Unicast means one-to-one communication. Anycast is also one-to-one, but one to the nearest one. And anycast works only on the IPv6. We don't have anycast communication in IPv4. This much information is good and good. Okay. You can write, I will share this PPTs with you, but you can quickly write down what is unicast, multicast and what. Here I've made the diagram. See, sender is sending it to the receiver. Correct? Multiple colors are there. I'm sending it to the one person. That is unicast. Here multicast means a specific group of people I'm sending it, and broadcast I'm sending it to everyone. Here you see different colors. Whichever is nearby, I'm sending it to that particular person. That is called anycast. Okay. We are going to learn what is local area network. What is LAN? Local area network. That is the answer we are not supposed to give, right? Okay. What is LAN? Local area network. See, within a building, when multiple devices connected and share resource with each other is called LAN. Okay. That means we are all sitting in this NH classroom, right? NH floor, second floor. We are all connected to one Wi-Fi. Say NH second floor. So that is a particular network. So that network is called LAN network. Likewise, there is a building next to ours. Okay. And that building, they will be connected to their particular Wi-Fi. So that is a different network. So within a building, when multiple devices are connected and share resources is called LAN network. Okay. Here you can see building, multiple devices, share resource. That is called local area network. Examples are school and library. So in library, you have a different network. In school, we have a different network. So those two networks are called LAN networks. Okay. Then we have campus area network. What is this campus area network? Within a specific area, multiple device share resource. Initially, we have seen within a building. Here it is within a specific area, meaning, see, school is a place, it's a single building, correct? But whereas university is what? It is a specific area, it is not a building. You will have a bigger circumference of area, right? So in that specific area, you will be having a IT department, you will be having a computer department, you will have a mechanical, civil, multiple blocks will be there, correct? So mechanical people will connect with mechanical Wi-Fi, civil will connect with civil Wi-Fi. Likewise, multiple different department will connect to their own Wi-Fi's. So those departments try to communicate with each other. That is called campus area network. Okay, within a specific area. Here you can see I've given within a specific area. For example, university and hospital. Hospital means what? Within a specific area. Here you can see hospital. Again, hospital will have multiple departments. You will have emergency department, you have outpatients, your operation departments, like multiple things will be there. So all those buildings, when they try to communicate, that is called campus area network. Okay. Now here I have metropolitan area network. That is within a town or city using RF radio frequency network, the users share resource is called MAN. That means metropolitan area network. See, we have understood LAN, that is within a building. CAN is within a specific area. This MAN is called within a town or city, meaning consider there is a police stations in Bangalore. You will have multiple police stations. So one in HSR, other one in BTM, other one in Marathalli, other one in Majestic, right? You will have multiple police stations. And if those police stations try to communicate with each other, then that is called MAN network. That means what? Within a town or city. Okay. Within that 50-kilometer range, if you try to communicate, then that is called metropolitan area network. Okay. For example, police station and also fire station. Fire station also, you will have multiple fire stations. Correct? You will have 4, 5, 6 within a city, right? According to the nearby thing, we are going to call that fire station. Same thing. Okay. So it connects offices, connects campus. So if it's office, consider there is a TCS office or Infosys. You think they will have only one building? So here they will have another office. There will be another office. So when they all try to communicate, then that is called MAN. Okay. Connects branches, bank branches, right? Data centers, all those across the city is called metropolitan area level. That means city level. Okay. Then we have wide area network. Wide area network. That means using a specific service when communication occurs. That is called wide area network. What is this using a specific service? What does specific service mean? Tell me. Correct. That means ISPs, Internet Service Providers. Okay. For example, we are all connected with Jio or Airtel, whatever the broadband you're going to act fiber, anything it can be. Using that specific internet service when communication occurs. I'm in Bangalore. He is sitting in Nellore. You are in Kerala. He is in some other state. So when those kind of communication occurs, that is called wide area network. Okay. So now you know the difference between LAN, CAN, MAN and WAN. Though we are learning, you're going to start a career on networking, but we never had a time where this networking thing started. It was started in the year 1945 by your Department of Defense, American. Okay, so American Department of Defense, they started this networking for the first time. Why they started? Because there was this war going on, right? They wanted to communicate from US to Europe, correct, during the Second World War. At that time, see, if someone wants to share resource from this part to that part, then he has to give a letter on thing. So the person will carry from US and he will take it all the way across Europe. That's the only way. So there is a high chance that letter might be dropped somewhere. A person can manipulate the letter, or simply he can change the letter, right? These are the disadvantages we have in your what do you say, when you're trying to send a person. So they came up with this concept called networking. What they did is they found this TCP/IP model. With this TCP/IP model, I'm able to send a resource from US to all the way to Europe with a single click. And if someone change the data, I will come to know. If someone manipulate the data, I will come to know. Or if they simply delete the data, I will come to know. Everything is done. And it is more safer also. So they bought it in the year 1945. That's where your networking started. Communication between two devices from one location to another location. Okay, good answer. Anything else? Okay, good. Communication between two devices. Okay. All right. We'll learn what is network. The interconnection between two or more nodes. In simple, you can say interconnection between two or more nodes is called network. Okay. If I'm connected directly to you, then that is also one network. Consider this is a classroom. We are all communicating with each other. So we are all devices inside this classroom and we are all one network. There is another classroom. Okay. That is a different network. There are people sitting in that particular classroom. They belong to network 2. We belong to network 1. And third floor, there is another classroom. People are sitting there. They belong to network 3. So we are also sitting in one network. That is a different network. That is another network. When you connect between interconnection between two or more nodes is called network. Okay. Why we require network now? Now a question comes, why we require network? We just discussed, if someone has to send data from one location to another location, he has to carry it. He will write it in a letter, say a postcard. That postcard has to be sent from this person to that person. We don't have a chance of writing nowadays, right? Because WhatsApp, email, everything has become social. We don't even experience that. It has become like that. But initially they were doing that. But if I'm going to write a postcard, again, it is not secure. Why it is not secure? Someone might steal your data. See, in networking also the stealing is there. Correct? Someone can steal your data. But that's why we deploy firewalls, security concepts. Those we will keep it aside. But it is more secure, your networking thing, comparatively. Data integrity. Because what is data integrity? This integrity word keeps coming in your networking. Data integrity. The person sitting in between, Hari Krishna, can change the data in between. Right? He can change the data and send it to Sharith. Now, if I identify that, that is called data integrity. I should make sure whatever the details I've sent, same details should receive Sharith. That is called data integrity. If even a comma has been changed to full stop, then there is no data integrity because that has been manipulated. If I convert a capital A into small a, is the data integrity there? No, it is not there because the hash values will differ even from capital A to small a. A is A only, but when you change capital to small, the hash values will change. So whatever the data I'm sending, that should reach the Sharith. Then only the data integrity is there. Okay. And then reliable. What is this reliable? I'm sending a data. Okay. Now, due to some internet issues, the data got dropped. But again, I can resend to you. I'll resend the email. If I'm writing a letter and due to some natural calamity, you lost the letter or the letter got damaged, then what I have to do? Again, I have to write it. Again, I have to send the person. But this is what? You're one click away. Just resend it. Done. So it is reliable. Cost and time, high speed of communication. If I want to send a data, just write a mail, give the email ID. Say, for example, there is one of your online guy, online friend, he is from Germany, right? If I want to send a data from here to Wisdom, who is sitting in Germany, how long will it take? At least 2-3 days. I have to put it in the airport. Then the thing will go there, then he will reach it. But in the email, I can simply go, I can say, okay, this is the thing, then enter, done. So cost, time wise, high speed of communication. These are the advantages of our network. Okay. So what is network? It is interconnection between nodes. Why we require network? These are the things. We have simplex, half duplex, and full duplex. What is this simplex communication? Simplex communication means one-way communication. It is a one-way communication. That means sender is sending the data and receiver is just getting the data. He cannot reply back. For example, your TV channel. Okay, you're watching it news, right? You'll keep watching the channel. You'll keep watching the TV. But will you be able to reply to that person? No. If you change the channel, will that affect that person? No. But again, if you go to the channel, will you be able to see? Yes. That means what? He will keep sending the data, you will just keep receiving it, but you cannot reply back. That is called simplex communication. Okay. And that we call it as one-way communication. Okay. For example, you can say FM radio. FM radio, you will keep hearing the songs. You can change the frequency. But again, if you change the frequency again you will get the same channel, right? Same thing. And then you have half duplex. Half duplex means what? Two-way communication. I mean, sender can send the data and receiver can reply it back, but one at a time. That is very important. But here you can see one at a time. What is this one at a time? Sender will send the data to receiver. Meanwhile, receiver should not send the data. After receiving it, then he will send the data. If you see the example, you will understand more clearly. Walkie-talkies. When the police, they use the walkie-talkies, they say the word over. Right? Why do they say the word over? Because until then, he will not speak. Once he receives that over word, then the other person will speak. If both speaks at the same time, then what will happen? Frequencies will mismatch and collision will happen, and then the device will go down. Or the data can be received. Mismatch of frequencies will be there. Okay. So that's the reason we don't use. You can use the same channel to communicate across this one. If it's a call, phone call, then everybody has to be in the phone call. Yeah. But this is not required. Okay. And here we have full duplex. Full duplex means what? Again, two-way communication. Sender and receiver can send both the data at a time. Like your WhatsApp call or a normal phone call. So both the people can talk at the same time. That is called full duplex. Okay. Here I have another thing. Here it is. See, half duplex means two PCs are there. Direction of data at a time, direction of data another at a time. But full duplex means both at the same time. Okay. So this is called half duplex and full duplex. Half duplex, we are not using half duplex anymore. Our mode of communication is completely full duplex. If you can't reply at the same time with me, then what is the use of that? This is they are using in the walkie-talkie still because of that secure communication. So they have one channel. In that channel, everybody will be communicating. You cannot communicate to the particular channel. For more security purpose, they're using it. But when you come to networking domain, everything is full duplex. Now, next thing I'm going to teach you is network devices. That is, what are the device? Why this device is not we are not using nowadays. In that, you will understand why we are depend on full duplex. Okay. Now we will learn this networking device. Okay. We have a device called hub. Correct. This is your hub device. It is a layer one. How many layers are there totally? Any idea? 7 layers are there. In your OSI layer, we have 7 layers. We have layer 1, layer 2, layer 3, 4, 5, 6, 7. Okay. Okay, 7 layers are there. In this, you see physical, data link, network, transport layer, session layer, presentation layer, application layer. The first 3 layers are called as hardware layers. Why we call it as hardware layers? Because all your hardware devices works on that particular layer. Okay, for example, if you take physical layer, okay, your hub, PCs, your laptops, your printers, your cables, all those things works on physical layer. In data link layer, your switches will work on data link layer. Okay, in network layer, routers, your servers, your firewalls, all these devices works on your network layer. Okay, these are physical layers. And here you see application presentation session. They are called as software layers because those are virtual. Okay, and here you see this transport layer is called as heart of OSI. Why we call it a heart of OSI? We'll discuss in OSI layer. Because that is the medium of communication between the user support and network support layer. Okay, right. Now come here. It is a layer 1 device. What is layer 1? Physical layer. Okay, and here one interesting word is there. We call it as a dumb device. There is a networking device and we are calling it as a dumb device. Correct? Are we supposed to do that? We still call it because there might be a very big reason we call it as a dumb device now. Are we using hub right now? No, we don't do hub anymore. We don't have hub anymore because it is completely replaced by switch. We don't have a hub. So why it is replaced? That we are going to learn now. Okay, it is a dumb device and it is a single broadcast domain and single collision domain. And one more thing here you have to focus, that is what? Half duplex. Okay, just read this one. Now I will tell you why exactly it replaced. Okay, layer 1 dumb device, half duplex. Now come to switch. This is your switch and it works on layer 2 device. We call it as intelligent device and it is a full duplex. Okay, it is a single broadcast domain. Hub is also single broadcast domain, but here you can see it is a single collision domain. But here what it is? Per port collision domain. This is very important. See, sometimes in interview people are very nervous, right? They are not used to these interviews, right? Straight away they will come and attend the actual real-time interviews. So okay, you guys are in the networkers home, so you will have multiple opportunities, multiple mock interviews you can give. There is no limit. If you want to give 10 interviews, you can give 10 interviews, up to you. But a person who don't have this opportunity, he will directly go for a real-time interview. So initially he is not used to this interview. He'll be very nervous. By seeing itself, the interviewer will come to know, okay, he is nervous. Then what they will do is, to make them little more comfortable, they are going to ask you very, very basic question. Okay, if a fourth standard student is sitting, if I'm asking A for, he will say apple. B for ball. You will confidently say the answer, right? He is not even going to think it. Immediately A for means apple word will come. Same like that. They will ask you, okay, tell me difference between hub and switch. They will ask you. So that is a very simple question. A person who has done CCI security or CCNP level, NFIX level course, he should know what is the difference between hub and switch. So you will answer that question. Then they will ask you, what is unicast and anycast? You know that you will answer that question. Okay, what is the difference between full duplex, half duplex? You will answer that question. Then you will be a little more comfortable. Then they will start the actual questions. But consider if you don't give the answer for that. Right? If you don't give answer difference between hub and switch, then what we can do? Right? So that's why you should understand what is it. Why it is replacing, you have to give the answer technically. Just not reading those points. If you read those points, they will hear everything. Next question comes up. Okay, can you explain this per port collision and single collision in detail? They will ask you. So technically, we are going to learn now. Okay, right. Come to this part. Here, okay, this is a four PCs are there. PC 1, 2, 3, and 4. Okay, and there is a hub in between. Now my task is to communicate from PC 1 to PC 3. Okay, I want to communicate from PC 1 to PC 3. So I will send the data to hub. Hub will send the data to PC 3. Right? How this thing works? See, the single collision domain and half duplex. Both we will be seeing it here. First, initially the PC 1 will send the information to hub. Right? He will send the information to hub. Now hub, what he will do? He doesn't know where is PC 3. Okay, I'm entering this classroom. Okay, I don't know where Hari Krishna is sitting, but I know someone is there in the group called Hari Krishna, but I don't know where he is or who he is. I will enter this classroom, right? And I'll ask, who's Hari Krishna? Then who will answer? He will answer, hi, it's me. Hi, Tamil, it's me. Then I will come to know about him. Okay. Now, tomorrow I'm coming into this classroom. Will I ask again, who is Hari Krishna? Why I will not ask? Because I already know. Already know means what? I will keep it in my memory that he is Hari Krishna. This is how he will look. I will read his face. I'll remember his name, which I'm able to do it. Whereas your hub is not able to do that. Meaning, PC1 is sending the information to hub, right? This hub, what he will do, he will first initially he will do the broadcast. Okay, he will ask who is PC3. Is this PC3? He will drop it. Is this PC3? He will drop it. Is this PC3? Yes. So what he will do, he will reply back to the PC1. Okay, now again tomorrow PC1 is trying to communicate, or the next time PC1 is trying to communicate. He sent the data, again he wants to send another data. He will send it to hub. Now hub, what he should do? He should directly send to PC3, right? But again he will send it to PC2, PC3, and PC4. Now when PC3 is, this is interesting, when PC3 is replying back to hub, it should directly send to PC1, right? But still he will send it to PC2, PC4, and also PC1. So every time when communication occurs, hub will send to each and every other devices connected. Okay, whoever is connected, he will send it to everyone. Now consider another scenario. Now consider another scenario where PC4 wants to communicate with PC2. Okay, now he will send it here. Right, he will send it here. Now what hub will do, it will send it to PC1, PC2, also PC3. Now PC2 will reply. PC2 will reply to hub. Again he will send it to PC3. Again he will send it to PC1. Again he will send it to PC4. So this is the problem we have. I don't want to send the information to PC1 and 3, but still the hub will send it to all the connected devices. Consider there are 5 devices connected. All the 5 devices will receive that information. This is called single collision domain. Now what is half duplex? Here we have half duplex. What is half duplex? Now PC1 wants to communicate at PC3 like this. PC1 wants to communicate with PC3. Same time PC2 also want to communicate with PC4. Then what will happen? Collision will happen because they are half duplex. Only one at a time can communicate. He will also communicate, he will also communicate, then collision will happen and hub will go down. Okay, this is called half duplex. That's why we don't use half duplex devices anymore in your enterprise level or anywhere. Okay. What is single collision domain? Each and every time it is going to communicate with every devices. Okay. Any doubt on this part? No. Now we'll compare with switch. This is your switch. Right? Okay. I have my switch here. Now I want to communicate with PC3. Okay. So he will send it to here. Right? And then what the switch will do? Will he directly send to PC3 or he will send it to everyone? He will send it to everyone for the first time. That means I'm coming into the classroom. Consider I'm a switch. I will come to this classroom. I will ask who is Hari Krishna. Hari Krishna is going to say, hey Tamil, this is me. I'm Hari Krishna. Now I will remember him. I will remember him in my memory. And tomorrow I will come directly. I will say, hey Hari Krishna. Correct? Same thing. First time when the PC is trying to communicate with PC3, switch will send it to everyone, asking who is PC3. Okay? And will he reply? No, he will not reply. He is also not going to reply. But who will reply? PC3 will reply. He will send it directly to PC1. Okay. Now again, what is happening? PC1 wants to communicate with PC3. Now it will send it to PC switch. Now what will switch will do? He will directly send it to PC3. He will not send it to PC2 and 4. Why? I'm a human. I'm remembering Hari Krishna's face. Is switch human? No, it's a device. So what it will remember? Your switch will remember the MAC address. Your router will remember IP address. Your switch will remember that MAC address. So since it's remember this MAC address, that is the only reason it is directly sending it to PC3. Okay. Now PC1 wants to communicate to PC4. Did any communication happen between PC1 and 4? No. So he will send it here. He will send it to everyone asking who is PC4. Now PC4 will reply. Now he will remember the MAC address. So next time if anyone wants to communicate with PC2, PC4, he will directly send it here. So that is the reason we call it as intelligent device. Hub we call it as dumb device. So this is called per port collision domain. Each and every time it is going to send it to all other connected device, that is called single collision domain. What is full duplex here? Simple. PC2 also can communicate to PC4 and PC1 also communicate with PC3 at a time. Your collision will not happen because it is a full duplex device. Clear with this part? Now you understand what is per port collision, what is single collision. Now come to this PPT. I don't send anything. You will be the medium. If I want to send information to Pinky, I can't send it directly because you are there in between. So I will send it to you. Whatever the message I am giving it to you, you will pass it to her. Okay. Now we are going to learn router. A router is a what? Layer 3 device, right? And it is also called as intelligent device. It is a full duplex. It has per port collision domain. But one different thing you will be able to see here. What is it? Per port broadcast domain. But here it is single broadcast domain. What is this per port single broadcast domain? We are going to discuss now. See. Okay. Now, switch 1 is here. Okay. Now I don't know where is switch 2, 3, 4. So what the switch will do? It will generate a broadcast packet, right? And it will forward to everyone asking who is switch 2, switch 3, switch 3. Will switch 2 reply? No. Switch 4 will reply? No. He will reply it. Right? Now, if I say send it to, say for example, switch 5. Is there any switch 5? But still the switch will send it to everyone. Reply will not come. He will just leave it. That is called single broadcast domain. One broadcast means one network. Okay. But what your router will do, routers per port is called broadcast domain. Per port. Every port is a one broadcast domain. So here you will be able to see router 2. If I say send the information to R3. Now what will the router will do? He will not send it to 2 or 4 even for the first time. Directly he will send it to R3. If I say send it to R4, he is not going to send it to R2 or R3. Directly he will send it to R4. Why? Because already he will have the information in its routing table. Okay. Now if I'm saying send it to R5, is there any R5? He will check its routing table, then directly he will drop it here. He will not even forward the packet. Okay, that is router. Single, per port broadcast domain. Broadcast domain receives all broadcasts. Collision, where data collision occurs. Receives all data means see. Here, I will be I'll be able to send directly to this particular device. Okay, so that is called broadcast domain. Whereas switch, every time it is going to send it to all the connected device for the first time. That means it is a single broadcast domain. It is within the network. But router is someone who can communicate with different network. So per port broadcast domain. Okay. Now you know what is single collision? Per port collision. What is single broadcast? Per port broadcast. Any doubt on this part? Per port collision. That means, again, within the network. Broadcast means outside the classroom. We are all sitting in this classroom. I am asking you a question. Pinky, do you understand? And you are giving me answer. Again, I will ask you, Pinky, you understand? Again, you will give the answer. That means every time I'm going to ask you the same question, what is your name? What is your name? That is single collision. Every time. I can't remember anything. Every time I keep asking you the same question and I will ask it in front of everyone. Guys, who is Pinky? That is one time I'm asking you. In tomorrow also I'm asking who is Pinky. Third day also I'm asking the same question. Because I can't remember anything and every time I'm passing the information to everyone. Now what you are doing, who asked you the question? As a trainer, I am asking you a question. But what you are doing is you are saying the name, okay, I'm Pinky, and you are giving that name to each and everyone. Did they ask you? But still you give the name. My name is Pinky. My name is Pinky. You are telling to everyone. That is called single collision. Purport means what? You will directly send it to tell me. Single collision, each and every time any information I have, I will share it to everyone. Reply, you should give it to me, but you are giving it to all four and also me. That is called single collision. Purport, directly. I'll ask you, you will reply me. Okay. Right. Now I have a small task for you. By seeing this device, I will give you 3 minutes time for you, 3 or 4 minutes time for you. You are going to tell me how many broadcast domain, how many collision domain are there in this topology. I will ask you everyone. So everyone has to give the answer. Take 3 minutes. Okay. Now you have the notes in your note. So what is purport, broadcast, single, you know. So how many broadcast domain, how many collision domain are there? Okay. This is a scenario based question they will ask you in interviews. Okay, they will make a topology. They will say 3 routers are there. All 3 routers are connected to 3 switches, and each switch is connected with 555 PCs. Tell me how many broadcast domain, how many collision domain. Then you have to imagine a topology like that. Otherwise, they will give you a picture like this and tell me how much. They will write down the topology and give you in a paper. Otherwise, they can ask a question. 3 routers are interconnected with each other, and then all 3 routers are connected with separate switches, and each switch is connected with 5 PCs. Why 2 broadcast? Router has per port. So this is one port. This is another port. So in this port, how many devices are connected? Switch, hub, PCs. It doesn't matter whatever it is connected in the under this, because they are all single. They are all single broadcast domain. So all these will come into one broadcast domain. Likewise, this is another port, and this cable is connected with multiple devices. These will come into one broadcast domain. So 1 and 1. Okay. The answer is in the picture itself. That's why we have made a box. One box, another box. Okay. All right. Now see. Now tell me, I'm connected with a switch here. Correct. In this switch is what? Per port collision or single collision? Per port collision. So how many port I have here? 1, 2, 3, and 4 ports are there. Right. And this third cable is connected with hub. Hub is how many collision? Single collision. So this completely will be taken as 1. Okay, this completely will be taken as 1. So 1, 2, 3, and 4. Come to this part. 1, 2, 3, 4. Right? But this 3 is connected with a switch. Switches again per port. Here I will again add 1, 2, 3. Here switch to switch will be taken as 1 collision domain. Between switch to switch. Okay, this 3 is common for this also. This also. So here I have 4. Here I have 4. And here I have 3. So answer is 11. So 11 collision domain and 2 broadcast domain. Nobody got close, huh? All out. All out. Okay. Now understood?
Yeah.
Right. Okay. Now I'm going to give another topology and you're going to tell me that. Now I know how many of you understood. How many of you are physically present and
Yes.
mentally absent? Now I will find out. Okay. Oh, answer. Oh. Now you can't ask me the question that what is the question? Why? Because already question is there. What is broadcast and collision domain? Now tell me how many collision domain? How many broadcast domain? Yeah, if you want to give the answer, you can just say the answer and then mute. Okay. Wisdom 12 collision, 5 broadcast. Okay, very good. Sharith has done, when I say per port, he calculated every port. No. So here I have one port. Here I have another port. So this is 1. This is 2. So here between these two, we are connected with the same router. So this will be one broadcast only. Okay. When this port is directly connected, one broadcast. This is another broadcast. Here to here, another broadcast. Now here, another broadcast. So how many broadcast domain? 5. Whoever said 5, answer is correct. Now comes the main picture, right? That is trailer. Now actual movie. Switches per port 1, 2, 3, 4. It is connected with hub, so completely they will be 1. It doesn't matter how many devices are connected here. So here it is 4. Now come here. 1, 2, 3, 4. But this 2 is connected with a switch. So I have to calculate this also. 3 devices are there. 5, 6, 7. So here it is 7. Now here switch is there. 1, 2, 3, 4. 4 is connected with hub. It doesn't matter what they are connected with. So here it is 4. So 7 plus 4, 11, 11 plus 4. So 15 collision, 5 broadcast. I suppose you guys forget to add these 3. You said how much? 13 you said. How you got that? Huh? This one you got correct, but here you have taken 3 only. You did not calculate this part. But it is connected to a switch. So that you have to take it as 1. I think this way you left 1. This also you left 1. That's a mistake you made. Now you have idea how to calculate it. Yes. Today, so what we have discussed as of now, starting from what is LAN, MAN, CAN network we have discussed. What is unicast broadcast we have discussed. Simplex, half duplex. And then what is topology? No, topology I didn't come. Hub, switch, router, broadcast domain, collision domain we have discussed. Now we are going to see topology. What is topology first of all? Graphical representations. That word is important. Graphical representation of how the devices are connected between each other. See, I will give you a scenario. Okay. I am telling, see, take this part. Take this topology itself. This is a topology. I'm telling 3 routers are interconnected each other one by one linearly. So R1 is connected to R2, R2 is connected to R3. Under R1 there is a switch and that switch is connected with 5 PCs. Under R2 there is a switch and that switch is connected with another switch. And with the other ports 2 PCs are connected. In the third R3 there is a switch connected with 2 PCs and a hub, and that hub is connected with 3 PCs. If I say like this, will you be able to get it? Can you imagine a diagram? No. If I'm having a rack like this, here you see a physical rack. These are the physical devices you see here. Can you, here it is not connected, but if it's connected, will you be able to say exactly which is connected to which one? No, you will not be able to say. That's why everywhere you go, even in your lab, you will be able to see the topology. Even if you go to a real world experience, there will be a topology. That means what? In simple, graphical representation of how the devices are connected. Okay. Here I'm telling you one scenario. 3 routers connected with 3 switches, and each switch is connected with 5 PCs. If I say this, how are you going to make a diagram? See, I am going to say like this. 3 routers. 3 routers. So 1, 2, 3. 3 switches. 1, 2, 3 switches. Right? And I'm saying 5 PCs each. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now they are all connected with each other like this. This is called topology. The graphical representation of how the nodes are interconnected between each other is called topology. When I just say, you will not understand. When you see with the real-time devices, you will not be able to see. So you need a graphical representation. Now you know where is R2. So this is our R2. This is our switch 2. This is our PC4. Where R3's PC1 is there. So this is R3 switch 1 PC1. R1 switch 1 PC1. Okay, this is called topology. Right? Now come to this part. What is topology? Graphical representation of a network. It displays how the nodes are connected in a network. Write down this 2 lines in your note copy. We will learn to see there are multiple types of topology: bus, star, ring, mesh, tree, hybrid. Okay. First, we will learn what is this mesh topology and then star topology. Okay, then we will go to the other ones. Okay, first mesh topology. Mesh topology means devices are interconnected with multiple paths. High reliability, no single point of failure. Meaning, how many devices I have here? 1, 2, 1, 2, 3, 4, 5, and 6 devices are there. Okay. Each and every devices will be interconnected with each other. Can you see R1 is connected with R2, R3, R4, and R5? This R2 are given different color combinations. So here it is connected with 3, 4, sorry, 3, 4, 5, and 6. And likewise, R3 is connected with 1, R1, I mean R4, R5, and also R1 it is connected. R6 also it is connected. So every devices is interconnected with each other. Okay, what is the advantage of it? Say for example, now this link went down. Okay, this link went down between R1 and R2. This link went down. Will I be able to communicate with R2? Yes or no? How? Because I can communicate with other way. Either I can communicate with R5 and then I can reach R2. I can communicate with R3 and I can reach with R2. Is that possible? Yes, it is possible. One link goes down in mesh topology, still communication is possible. Correct? That is the advantage we have. What is the disadvantage we have? It is more complex. Correct? Can you see? See, for example, now I'm going to add one more router. Okay. I have added one more router. Now this router has to be connected with each and every other devices. So I will connect it like this. Look how clumsy it has become. More complex it has become. Just I've added one more router. Now if I add another router, then how many links I need? Tell me. I'm adding one more router. How many cables I need? 7 cables. So 1, 2, 3, 4, 5, 6, 7 cables. 7 devices are there. All that 7 has to be connected with my 8th device. So I require 7 cables. If I add one more cable, one more device, then 8 cables. So as many devices are there, that many cables are required. It is very complex. And more importantly, what? Any organization, they will try to cut down the cost. They will always try to cut down the cost. If I'm going to have a mesh topology, then I require more cables, right? I need a bigger server room. Then I have to rent a space. If it's a data center, then it has to be less than 0 degrees. Do you know that? Data centers are always maintained at minus temperatures because it will produce an immense heat. Okay, if one server turns on, it's going to become a big heat. Imagine multiple hundreds and hundreds of servers. So it will be maintained at minus degrees 24/7. So bill, electric bill. So every way it is increasing. Space, electric, cables, multiple people required to do the configuration and cabling. So everything it is increasing the cost. So they don't do it. But where they're using this mesh topology, mostly in the internet side. Okay, internet side, because we can't afford a network failure. Because of a link, you can't say that network is down. Okay, in the ISP sites, they're using this mesh topology, but not on the enterprise level. Then you can ask me, then if what if a link goes down in the enterprise level, what can be done? For that only, we are going to learn redundancy protocols, which I will teach you. In the star topology, there is a central device. Okay, and all the other devices are interconnected with this particular central device. Okay, and if communication has to occur from PC1 to PC4, then it has to go via the particular central device. Okay, now the advantage of this star topology is what? Less cables, more simple, easy to handle. See, if I want to increase one more PC, then what I will do? I will simply say, I will simply take one more PC like this, connect it like this. Very simple, right? One more PC, again, keep it like this, keep it like this. That's it, right? Anything else? No. Very easy. So easy to manage, easy to configure, and more simple. advantage. But what is the disadvantage? Correct. Consider if this link goes down, will I be able to communicate to PC1? No, I cannot able to communicate. But in mesh, that is possible. Okay, consider if this switch goes down, then complete devices will go down. Nobody can communicate to each other. So that is the problem we have in star topology. So this is called mesh and star topology. Okay. Now come to this part. Initially, we had this bus topology. Now we are not using this bus topology. Okay. Why? Because there is a single line. In that single cable, we are connecting this multiple devices. If that cable goes down, again, everything is gone. So we don't use this bus topology anymore. Okay. If the backbone fails, entire network fails. There is a high chance of collision in this bus topology. That's why we don't use this. Okay. Star topology, we are using it. Initially, we have this ring topology again. Ring topology, it is in the same direction. The network will be flowing. I mean, the packets will be flowing. If one device goes down, again there is a problem. The device cannot go through the get the other information. So we don't use the ring also. We seen what is mesh. Tree topology is nothing but extended version of star. Okay, multiple star topologies are there. That means this I will teach you the core layer, distribution layer, and then we have access layer of switches. How in a real world, how the topology will be arranged. Here I will show you how the tree topology is there. That means it's a mix of multiple star topology. Okay. And then we have hybrid. Hybrid is nothing but mix of both star and mesh. That means, see, if there is an office, okay, in that office, mix of star plus mesh plus tree means office is like a star topology. Okay. In my office, multiple branches will be there, departments will be there. So I will give the multiple departments. So that buildings are there, right? If you take Google, they will have multiple buildings. So each building is a star. Okay. And then we have a mesh topology. How mesh topology? WAN networks. Your Wi-Fi's will be there. So that will come under mesh topology. Okay. And then that Wi-Fi is called as mesh plus star. I will show you again in the topology. So simply you can say hybrid means what? Mix of mesh plus star. Tree means extended star. So two things you have to remember. What is mesh and star? If you understand these two, other topologies will become easy. Okay. There is one more PPT with me. I will share you this also. Straight through, crossover. Okay. We have rollover. We have console cable, fiber optic cable, coaxial cable. Here also I have one PPT. What does this straight through cable mean? See, when I'm going to connect between different devices, then I use straight through cable. If I'm going to connect between router and switch, then I will use straight through. Switch to PC, straight through. Switch to router, straight through. So where this straight through cables comes into picture is between different devices. Where my crossover cable will come into picture? Same device. When I want to communicate with the same device, then my crossover cable will come into picture. Okay. Router to router, same device, crossover cable. Switch to switch, crossover. PC to PC, crossover cable. Okay. And there are two types of line color combination. Here you will be able to see. Here you see white, green, green, white, green, green, white, orange, blue, white, blue, orange, white, brown, brown. This is A part, TA. TB is what? White, orange, orange, white, green, blue, white, green, blue, white, blue, green, white, brown, brown. Okay. When TB is connected with TB, then that is called straight through. So both the end will be the same color combination. TB, which says TB, is called. Here, if you see it closely later, you will be see the color in the wires. Okay. This wire color is based upon the cable, what cable we are choosing. If it's a straight through cable, what you see here also will be the same. White, you will have this color combination of color combination. This side also, this side also. Okay. What is crossover? You will have opposite. Between this, TA and TB will be there. That is called crossover. Rollover means what? If I am having, say for example, ABC color, the other side I will have CBA. Whatever they are having here, exact opposite I will have there. That is rollover cable. Okay. Now come to this part. Straight through cables are needed to connect a switch port to a router or a host. It is used to connect different types of devices. This is your standard Ethernet patch cable. Okay. When I'm connecting with a different devices, we are using this straight through. And then crossover cables are used to connect similar type of devices. Right. And then we have serial cable, but we don't use the serial cable anymore. Able to see? Serial cable, we are not using it anymore because it doesn't carry a lot of data and very slow in speed also. Okay. And then we have console cable. That is, see, if you're purchasing a real-time device for the first time, okay, if you're purchasing a router, it's a fresh router, it will not have any configuration. Then what I will do, I will take a console cable. In the router console port, I will connect it. The other end, I will connect it to my PC. Okay. For the initial configurations part, we are using this console cable. And then we have fiber optic cable. Fiber optic cable transmits large amount of data. Initially, we are having copper wires, but we don't use copper wires anymore. We are depending upon fiber optic now. Why? Because it is lighter. It can send more data, very flexible. Okay. Because it is going to transmit the data in the speed of light. Whereas copper wire will send the data with the speed of electrical signals. Here it is light signals. What is speed of light? 3 into 8. Don't worry, they will not ask these kind of questions. Even I don't know. Okay. But it will transmit light signals. It will be faster than copper wires. Okay. So these are the things we have discussed in today's class. On short note, starting from unicast, simplex, LAN manwidth networks, what is network, what is topology, what are the types of cables, what is hub, switch, router, collision broadcast domain we have seen today.